Hi, my name is Serhiy. I work with the New York Times. I live in Toronto, Canada, so this sunny and warm weather that London is famous for is like a big pleasure for me. My team where I work is called Application Delivery, and we are responsible for the experience of application delivery in our IDP. This is my dog. I just really think that he's cute and I miss him. So the question that I often receive at KubeCon is, why do you need such an complicated infrastructure? Why do you have so many engineers? It's just a newspaper. In 2025, New York Times is more than a newspaper. We are digital media with a strong focus on technology. So that reflects in our portfolio of products. Besides the news and interactive articles, you can find yourself playing the games, including the Wordle, listening to audio podcasts, and also my favorite is cooking and Wirecutter. Argo CD plays an essential role in our IDP and deployment process. Our colleagues have given wonderful talks in the previous years. I'll share some links to them at the end of the presentation. So let's touch base on some important concepts. For example, service level indicators is a measurable metric that indicates the performance or reliability of your system. For Argo CD, the examples might be the percentage of successful sync operations or sync duration. For my dog, it would be like the number of barks per hour. Service level objective is the objective, like the target that you set for your SLI that should be achieved over some period of time. For Argo, for our examples, it would be that 95% of sync operations should be successfully completed under 20 seconds per last 30 days. And my dog should bark at least 5 times per hour. So the traditional monitoring approach was a great backbone for many years for system reliability. It's a great tool when you need to debug some incident or performance degradation. You can build the dashboard where you will display and see at one glance all the system information like CPU, memory consumption, network data, some cloud metrics, and also the application and application logic metrics, like the number of active users, number of Go routines, etc. Usually, everyone is excited about the immediate alerts that you receive over the weekend from your pager duty about some critical incident. That might be annoying, that it's great, but it greatly reduces the time to response for the incident. And having the historical data and charts gives you like this ability to analyze and find the patterns. From our experience in our team, for example, having the CI charts and CI data from the long period of time, we found some unusual spikes of builds that were triggered by Dependabot. So we tracked down it to Dependabot and then adjusted the schedule. And now Dependabot sends those updates over the weekend or in the night. That's a great benefit of traditional approach, but there's always some drawbacks. It tends to be the reactive response. You receive the alert, and then you start to investigate the issue. That means that there is already some impact for your customers. Or like the opposite situation. You have so many alerts, and they are triggered so often that you just hit the snooze and wait till they will be resolved by themselves. So that's like the big problem with alerts, the alert fatigue and data overload. But one of the biggest problems is, those metrics, does they answer the question, are your customer happy with your service? So SLI and SLO approach transforms the way how we look at the service reliability. We should choose the customer-focused metrics, those that would be important for them and useful. Having the error budgets gives you like the tool and framework how you can have the data-driven approach to choose the priorities for the next work. So So error budgets, it's simple words. If you have your SLO 99.9%, then the remaining 0.1% of time or error events or successful events is your error budget. It's something that you assume is acceptable level of degradation of the service. And then you start to improve your reliability or performance only when you are out of the budget. So this gives you like this freedom to innovate. If your budget is healthy, you can ship new features, experiment, innovate. If you are out of the budget, then probably it's a good idea to focus on reliability and performance. And also one thing, it gives you the clear way to communicate with service users and managers on what should they expect. In simple words, like you on the planning say, yes, we can spend like 5 weeks improving this and these parameters, but that would only help us to reduce the downtime of the service for 2 hours per month. Does it worth it or not? So when we started to work on Argo CD SLOs, we were inspired from our experience with CI. This is some screenshots of real world, some of the dashboards that we had for drone CI, the systems that we use. As you can see, there's like very important information for us as operators. We can see what's going on, but when we showed these dashboards to our users and customers, they were like, wow, that's impressive, and they never opened it again because it's too much information for them. They have their own tasks, they have their own code base, own dashboards. They don't have time and mental capacity to understand all this data. And still, we were receiving pretty much similar complaints from multiple teams. Hey, our builds are too slow. Our builds take too much time to start. So we transformed and changed a little bit our approach and defined multiple simple SLOs that were clearly explained, and we had this like simple dashboard to show the status of them. This gave us like the great way to communicate with our management and with our dev teams. This is the level of service and performance reliability that you should expect, and this is the metrics that we can compare that with. So when I started to work on Argo CD SLOs, I just opened the list of all available metrics. They are in the docs, or you can hit the endpoints in the cluster with your Argo installation. And this is not the full screenshot, but there's like were dozens and dozens of indicators, and targets were way off, and it didn't help end users to better understand the health of our system. So we did like a step back and decided to think what would be the better approach for this work. How you can transform the metrics into the meaningful SLIs. First of all, you need to identify the key user journeys. So you think about the critical paths that your users take in your system to achieve the objectives that they want to. Then you map those journeys into some measurable events on each step. And then those events should be transformed into the available metrics from Argo CD or systems near the Argo CDs that would help you to build the metrics and transform them into some Boolean indicator, fail or pass. So then you can calculate the percentage of successful events or failed events. Once we defined our indicators, we should set the targets, the objectives for them. How we can do that? First of all, let's analyze the historical performance. Having this thing, we can set the objectives that would be achievable and would make sense for us as platform engineers. But also we need to consider the user expectations and business requirement. We need to be good enough for them to use our system at platform. It's a good advice to start conservative and achieve those lower targets before moving like to higher targets. And of course, different components of our system might have different targets because of different importance in this critical path. Oh yeah, and last, we always need to communicate with the customers and adjust based on their feedback. So here's the simplified version of deployment in the flow or inside the Argo CD. Basically, Argo triggers the detection. It might be goes through the webhook notification or pulls the data from GitHub, then fetch the source of GitOps repository, manifest generation happening through the Helm customize, then application controller reconcile, get the live state of the application, and calculate the diff that should be applied. Then Kubernetes API is used again for update and create the new resources, assess the health of those resources, and then the sync is completed. The post-sync hook is fired, and if some notifications were configured, they are sent to the target destinations. Let's think about the common bottlenecks that might happen in this flow. You have the Git operations, so some large repositories, network issues, the big amount of repos at the same time might be the reason, so those requests will take significant time. The manifest generation, Helm and complex Helm charts might take a lot of time to process. Resource updates and reconciliations, they heavily rely on how fast is Kubernetes API. So if your cluster is slow, your destination cluster is slow, then it will significantly increase the whole process of deployment. And last but not least, at least our users, they get used to check the status of deployments from UI. So if UI is non-available or it's slow, it makes them anxious. But another thing that we need to keep in mind is that's our view on the deployment journey, on the flow. As a platform engineers, we know all these components. But for a lot of developers, they want simplicity. In their case, they commit and push the changes, then the black box doing the black box magic, and then it is deployed to environment. So the important questions for them: did my code was successfully deployed? How long it was taken? How long until my changes are on the environment? And can I check the status of the deployment? So we started to work on improving those list of SLIs and SLOs. First of all, we removed some unnecessary and unuseful indicators. For example, in our case, application set is used only for creating the new service. And the onboarding process to our IDP is built that way that there are other steps that take significant time. So we basically never receive the complaints about application set and service onboarding. So we decided to hide them, at least for now. Next thing was revisiting the queries for some SLI. And this screen, you can see the application sync successful count. So first, I was counting all the events, but then we realized that our single Argo CD, it handles deployments to production and non-production environment, including the PR environments. And those are designed and supposed to fail sometimes. So at the bottom screen, you can see that I choose only the metrics for the destination cluster of production targets. And last, some of the indicators, I just combine them into more complex query. So for example, the Git request performance was calculated separately for different type of request. But you can create the same query with different targets and combine that into one indicator. So here's the list, the full list of revisited SLOs. And you can see that some targets are still off. For example, the notification delivery, but that's the problem that we will work on. So let's go over some of the SLIs. For user applications, the application health is calculated and sync success rate. As I explained already, those queries are designed to calculate only production environment applications. The repo server, Git request performance is something that we already saw on the previous screens, but also another SLI was the pending Git request. It calculates as the maximum value over the 5-minute intervals, and it helps you to catch the events that are not even covered by the first SLI. So in case of some stuck problem. Pending Kubernetes request is the same approach, but for Kubernetes API request. The reliability of Kubernetes request, as you can see, the 404 is calculated here as a successful event because we expect that not all of resources present on the target cluster before we have the deployment. So that's a success. Another two SLIs for application controller is the reconciliation performance. We have the two different SLIs for that. One is for production and one for non-production environments. Because for non-production, I can imagine that that's fine if the reconciliation will be a little bit slower. Queue wait time. This one is a big query. And as you can see, it's different types of work queue calculated, but at the same time with different targets. This reduces the visibility into the SLO. So if your error budget is breached, you can't see from the first sight how and what was the reason. But for that, we built the dashboard, and some additional charts were supplemented to SLO. So as you can see on the left side, there is one number with error rate, and that's your SLO budget is out of the budget. But on the right, you have the charts for different type of the events, and you clearly can see that app reconciliation queue is the problem in our case, and we need to improve that thing. So what are the possible next steps for us? It's obviously the continuous improvements. We need to think about SLO, revisit them, and have the communication with people who would be looking at them. Update the dashboard with more examples like on the previous slide where you have supplemental charts for the single SLO. Use the CI metrics. In our case, manifest generation is happening inside one of the CI steps. So I want to use the metrics from CI to calculate the performance and reliability of the steps that are related to GitOps process. One of the ideas that I also have to leverage the webhook notifications inside the Argo to build the service that would receive all these webhooks and calculate some additional advanced metrics. It might be end-to-end deployment time, or the time when, how long the application were in out-of-sync state, maybe some DORA stuff like the deployment frequency. Yeah, the conclusion. So first of all, you need to be very careful and choose the right metrics and queries that would represent the potential problems in your system. It's a good idea to set up alerts on the error depleting. You will receive this notification early, and you can be proactive in working on system reliability and performance. Continuous improvements and communication with stakeholders of your SLOs. I'm really a big fan of infrastructure as a code approach, and having the Terraform code helped me a lot, like to iterate and have the list of iteration, and I was always be able to go back, you know, all these benefits of Terraform. Simple SLOs is the screenshot, the last screenshot, and the approach that I like. You have the one simple number, and then you have more additional information near that will explain for your customers how to do that. This is just a promo of talks from my colleagues. Please consider visiting them. One of these talks is today at ArgoCon, and other are in the following days. The list and links for some of the talks from previous years at CNCF events, where you can find more about how our platform is built, how Argo CD is used. Big thanks to Luke Phillips and Max Nee for helping me presenting this, helping to to do this work, and Eve, who is not here, unfortunately, and the whole app delivery team. Thanks for your attention. Feel free to message me in LinkedIn, CNCF Slack, and scan this QR code to send me a feedback. I'm always happy to answer the questions. Thank you.